Here, moving on, we want to look at situations where we're not necessarily going to get rational numbers as solutions and determine what we're going to do there. So right here, we've got x plus 1 over x minus 4 equals 0. And right here, the least common denominator is going to be the only denominator in this case, x minus 4. And right here, when we multiply by that x minus 4 on both sides, we are going to see a quadratic come for us. So right here, multiplying on the left side, we distribute, and we distribute x through x minus 4, and that gives us x squared. And then right here, minus 4x, and then we distribute to our second term. The x minus 4 that we're multiplying is going to cancel out with that x minus 4 that we're dividing 1 by. And right here, we would just get plus 1, and then this is going to equal 0. So pretty quick work here. On the other side, obviously, anything we multiply by 0, we get 0 for, so that's going to give us 0 there. And now right here, what we're going to see is that we've got a quadratic that we cannot factor. So what we're going to have to do is use the quadratic formula. Now, when we use the quadratic formula, we're going to say a equals 1, b equals negative 4, c equals 1. And right here, for our quadratic formula, that is going to give us x equals, and then a negative 4, plus or minus the square root of that negative 4 squared minus 4 times the a term of 1 times the c term of 1, all over, and then 2 times the a term of 1. So right here we can simplify this guy and solve them out. So we get 4 plus or minus the square root of 16. And then right here we've got 1 times a negative 4, so minus 4, over 2, which is going to give us 4 plus or minus, and then this is going to be the square root of 12 over 2. We can simplify this guy a little bit. We can say he's 4 plus or minus, and then right here we would have the square root of 4 times the square root of 3, which would give us 2 times the square root of 3. And then right here we can say that our two solutions are going to be x equals, and this is going to be 2 plus the square root of 3, and x equals 2 minus the square root of 3. Now right here we can say that these solutions would be approximately, and then 3.732, and right here we could call this guy approximately 0.267, we'll call it 9. Now right here, plugging these guys back into the original equation to see if they give us solutions is a messy process. So one thing we can also do to check to see if our solutions are both valid is to change our equation into a function, right? Type it into the calculator, and since it equals 0, right, since our equation equals 0, we can see if this function, right, has x-intercepts that correspond to these solutions right here. So taking out our calculator, we would plug in right here x plus 1 divided by x minus 4, and then graph that guy. That gives us this graph right here. We're seeing 2 x-intercepts that look pretty good, right? So right here we can go ahead and find those zeros by going to 2. And right here we would want to go a little to the left and a little to the right, and then press enter. And right here there's our 0.2679, right, 4919, right? And right here we can go back and check the other 0 to see if it represents our other solution. And we go all the way over. We go a little to the left, which in this case is going to be above the x-axis, a little to the, oops, that's a little far to the right. So right here, a little to the right, hopefully that's enough. Press enter, and then enter again. And right here we've got our 3.732. So both of these turn out to be valid solutions for our rational equation here. Why don't you guys go ahead and give this one a shot, and we'll come back and look at the solution real quick. Okay, so right here we can see that by factoring our quadratic, we get x minus 1 times x minus 3 in the denominator. And since those are both the denominators of our two terms on the other side, we can say that our least common denominator is going to be x minus 1, x minus 3. When we multiply that on both sides, we're going to see the multiplication and the division cancel on this side, right? And when we distribute that multiplication through to both of our terms here, in our first term, the x minus 1's cancel and give us the multiplication of 2x times x minus 3. And in our second term, we see the multiplication and the division of x minus 3 cancel, and we get the multiplication of x minus 1, and that equals 1, right, which was our numerator on the other side. So right here, at this point, we can simplify this guy. We're going to get down to this quadratic right here. We can't factor this guy, so what we're going to do is use the quadratic formula, and when we use the quadratic formula, we come to the two solutions we're seeing right there, these two irrational solutions, which give us these approximate x values as solutions to our rational equation. Now, if I take my original equation here and set him equal to 0 by subtracting 1 over x squared minus 4x plus 3 from both sides, I can turn him into a function, y equals, right? Type this guy into the calculator and see if I come up with these two solutions as x-intercepts. So right here, taking up my calculator, type this guy in, right? And then when I graph them right here, I've got x-intercepts that look like they're pretty accurate, and we can test them out by finding what they are, finding those zeros. So right here we'd go 0, let me go a little to the left with the left bound, press enter, go a little to the right below the x-axis, press enter again, and I'm coming up with my negative 0.3507, so that's approximately what I got right there. And then second trace calc again, and then of course the 0. So right here we'll arrow over to that other guy. And again, we're a little to the left first, press enter. You need to cancel that, whatever that is. And then right here, we'll go a little to the right, so a little below it, and press, we need it on the other side. And then I can press enter again, enter one more time, and right there I'm getting my other 0 pretty accurately at 2.8507, which we could round to 2.850 or 2.851. So right here, that's the lesson, guys. We'll go ahead and do a worksheet when we get in tomorrow. It's a little shorter, even though it was one video, longer video. But again, you guys can sort of fast forward this as you want, and then we'll look at this tomorrow. All right.